Okay, let's talk about geometry proofs. And these are problems that you typically start to encounter at the high school level. So if you're taking high school geometry and your teacher's giving you problems that say something like prove this or prove that. Matter of fact, let's go ahead and take a look at this example. This will kind of, clarify what I'm talking about. So given that angle 1 is congruent to angle 3, and I'm talking about what's going on in this figure right here, we want to prove that line L is parallel to line M. Now, these two lines appear to be parallel, but we can't write this down and be like, well, line L looks to be parallel to line M, therefore L and M are parallel. Well, of course, we're going to need an actual concrete justification, some proof. And this is no different than, how like a lawyer or an attorney, is talking in court, right? They're trying to convince a jury of something. They're saying, this, and then therefore it must be this, believe in what I'm telling you because here is the proof, right? To, say that my client is innocent or guilty, whatever the case might be. Well, of course, if your attorney is trying to say that you're guilty, you got problems. But anyways, hopefully you'll understand the idea that a proof is proving something. Okay, so you need to kind of put that kind of thinking cap on that. Okay, right, how do I justify something? Well, in mathematics, you have to follow very specific rules. And the rules or kind of the structure we're going to be using at the high school level in terms of high school level geometry proofs is something called deductive logic. Okay, so I'm going to be kind of going over what are very common type of proofs that high school students face when they take geometry. Now, I will say this, most students hate doing these type of problems, but just remember that there's not one way to prove something, okay? You could do a nice proof. It might be different than what your teacher would do, but it could still be technically correct, but you do have to follow very specific rules, and that's what this video is going to be about. But I will say one thing too, this concept of proving things is the essence of mathematics. My degree is in theoretical mathematics. And at the university level, most of the problems that I did, well, a huge majority of them would be things that had to deal with proving stuff. Prove this, show that. So this is truly kind of the essence of mathematics if you're just curious about that. But we're going to get to all this in just 1 second. Matter of fact, if you think you can actually construct a proof for this, that would be super impressive without seeing what I'm doing. But I'll talk about all the details here in a second. But first, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades. And I'm telling you right now, if you're struggling in mathematics, please don't give up. There is hope. What you need is great math instruction, clear, understandable, comprehensive. So if you're at the middle school, high school, or even college level, check out my Math Help program. You can find it a link. You can find it by following the link in the description. If you are watching this video, I assume you are interested in geometry. So I have a complete full geometry course that goes over a ton of proofs. Also, if you happen to be preparing for a test with a math section, there's a ton of them out there. Things like the GED, SAT, ACT, ASVAB, maybe a teacher certification exam. I have a ton of test prep courses that can help you out. If you homeschool, I have excellent homeschool math programs for middle and high school level mathematics. If you need a pair of math notes, I'm going to leave links to my math notes in the description of this video, but hopefully you have your own great notes. Okay, this is one of the keys to be successful in mathematics. And if this video helps you out, don't forget to like and subscribe. Okay, so proofs, big topic, and for most students, taking high school level geometry, they don't like doing these type of problems. So if you're like, yeah, that's me, well, that's what this video was designed to help those of you out there are struggling with proofs. But let's take a look at what a proof kind of is going to look like. So what we're going to be doing here is what we call a two-column proof. It's the most typical type of format for this level of mathematics for what you're going to be dealing with. Again, this is generally speaking, most of you out there taking high school geometry. It's kind of where this video is targeted at, but maybe some of you need to just review geometry in general. Okay, so a two-column proof is basically looks like this. Okay, there's two columns. Well, here, you're going to make a statement. You're going to say something. Then you're going to back that statement up. You're going to give a reason why you're saying that or justifying that. So you're going to make a statement, and then you're going to give a reason. Then you're going to make another statement, and then you're going to give another reason. But the statements have a certain flow. Okay, what you're trying to do is go and argue. Okay, you're trying to prove your final point. Okay, so you're trying to prove something, and it's no different than saying, to your best friend, hey, you're trying to, let's say, convince them of something, and you're debating or arguing about something. You say, well, don't you agree that this happened? They'll say, oh yeah, okay, yeah, that happened. All right, boom, right. So you say, okay, that happened. All right. Then you try to walk them to your next point. I'm pretty sure everyone, understands what I'm saying. Maybe it's your brother or sister or your boyfriend or girlfriend, whatever the case might be. You're like, okay, what about this? Now this happened, right? Okay, yeah, yeah, or that happened too. Boom. And so you're trying to step by step logically, get to a certain conclusion. Okay, this is the idea in doing a proof. But again, where there's very specific rules because when we're dealing with geometric proofs. All right, so we're going to give a statement and then we're going to give a reason, and we're just going to continue to make as many statements and back this up with as many reasons until we reach our final conclusion, until we have proved what we want to prove. Now, here's the thing. You can see I have some stuff going on over here. The reasons you can list. Now, here is the main kind of point, well, one of the main points of this video. The reasons that you can give aren't opinions. You're not going to say, don't you think that, these two angles are equal because they look to be equal? Because, I measure them on my paper and they look and they are equal. No, you can't give a reason like that. The only reasons you can give, okay, in a geometric proof, and this is kind of classic geometry, is the following. One is given information, okay? Now, what am I talking about given information? Well, let's go back up here. In this proof, I told you, given that angle 1 is congruent to angle 3, I gave you that information so you can justify that. And given information, your first statement is typically almost always going to be, you're going to kind of repeat that given information. Okay, so that's one thing you can give, but oftentimes you can use this given information, in other statements throughout the proof if you need to. So that's one allowable justification for a statement, okay, or a reason that you can back it up. The second thing is definitions, okay? So definition. So like a triangle has a specific definition of what it is, right? A circle or parallel lines, okay? They have very specific mathematical definitions, and this is where your notes come in big time. If you're not taking like notes in any math course, but especially in geometry, because you're going to be learning a ton of theorems, properties, postulates, axioms, corollaries. There's even these things called lemmas. There are a ton. I mean, like it can just like add up hundreds and hundreds and hundreds of these little definitions, postulates. You need to be highly organized and be able to call upon these, okay? And this is where I think where most students struggle with, and in terms of a geometry course, because they're not as good as note takers as they need to be. You need to have super organized notes. Now, if you need great geometry notes, okay, you can check out mine. I'm going to list those in the description of this video, but if you take my geometry course, you get access to it, you're going to have access to like all my masterwork, okay, that are going to have the notes and a ton more. But you need to have access to all the stuff that you've learned up to a particular point in your math course, okay? So that's definitions. Now that goes along with postulates, okay? So a postulate, right, is different than a theorem, okay? A postulate basically is something that we are kind of given. We prove theorems, okay? Postulates are kind of given to us. They're like, there's another thing in mathematics called axioms. We just assume them to be true, okay? Theorems we actually can prove. Now, I'm kind of skipping over this here for a second, just so you can kind of get this idea of theorems. You probably know what this is. A squared plus b squared is equal to c squared. That's the Pythagorean theorem, okay? That can be proved. We can actually do a nice justification to prove that particular theorem, okay? But a postulate are just, these are things in mathematics that we just kind of assume to be true, and there's another kind of word that goes for them, like axioms, okay? But postulates are typically, this word is used pretty heavily in geometry. Okay, so let's go on to our next reason here, and that's the properties of algebra and congruence. I'm going to show you some examples of what this is, but there's a lot of these as well. Okay, there's a ton of these, a lot of these, there's a lot of these, and of course there's a ton of theorems which I explained. So anytime you give a statement for a proof, the only thing you can say is that, oh, that's given information, this is a definition, this is a postulate, maybe this is a theorem, that's a definition. So you just can't have opinions. You got to back it up with these things right here. Okay, so therefore, you better have super great notes. Okay, or this is going to become very difficult. And that's why a lot of students don't like doing these proms, because there's no way you're just going to be able to remember all this stuff. Okay, so let's go ahead and take a look at some examples of properties of algebra and congruence. So what am I talking about? Well, here's just a couple of quick examples. There's actually quite a few of these things, but let's go ahead and take a look at a few. Okay, so you're probably saying, oh, I remember learning this kind of stuff. Well, let's take a look at the addition property of algebra. Okay, now you can just kind of abbreviate this is the addition property, but let's take a look at this. If A equals B and C equals D, then A plus C is equal to B plus D. Now this seems like very obvious, right? Look, if this is equal to this, okay, A is equal to B, well then if C is equal to D, well if I add C over here, A plus C, that's the same thing as B plus D. Okay, if you kind of study this for a second, it would seem like logical, right? It would be like, yeah, if A equals B and C equals D, then of course A plus C would equal to B plus D, but we need, this right here has to be justified. Okay, you have to back this up formally. Okay, so you'd have to say, yes, this is true because of the addition property of algebra. Okay, you just can't write this down. You have to actually know the name. Okay, so it is important that you can identify these properties, definitions, etc. by name, and there's no way you're going to be able to remember all this stuff. You got to reference your notes. Okay, all right. So let's take a look at another example of another property example in algebra, and this is the transitive property. Ooh, I'm missing a little N here. Transitive property. So the transitive property, big property. So here is the transitive property. If A equals B and B equals C, then A equals C. So it makes sense, right? If A equals B and then B equals C, all right, so I'm like, okay, A, B. So you can almost think of it this way. A equals B and then B equals C. Therefore, A is equal to C. It's totally logical. Well, you got to back this up. This right here is true because of something called the transitive property of algebra, okay? Now, let's go over here and take a look at congruence. There's also properties of congruence. Now, properties of algebra, you're typically going to have like an equal sign. Over here, with properties of congruence, we're talking about this little congruent symbol right there. So what is congruence? Well, congruence, here, if I said like the number 2 is equal to 2, okay, that is just like a property of algebra. Okay, that would be like the reflexive property. Now, we have a similar property. Okay, it's basically the same property, but we call it the property of congruence. But congruence has to deal with the measurement of like something that's given us a measure, okay, i.e., let's actually take a look at an example. So let's look at the reflective property of congruence. So line segment AB is congruent to line segment AB. In other words, here's AB. It's basically the same measure of itself, okay? Well, we can state that because of the reflexive property of congruence, because we're dealing with line segments, okay? We're actually measuring something. So when you're measuring line segments or angles, like here's another example of the reflexive property of congruence. Angle A is congruent to angle A. So this would not be the reflexive property of algebra. To be more technical about it, you want to have the reflexive property of congruence. But if I just said 2 is equal to 2, that would just be the reflexive property. That's a property of algebra. So going up here, okay, there are quite a few properties of algebra and congruence. They should be somewhere in your notes. Now, a lot of you are probably kind of flabbergasted at this level You might be going like this here, just like, this is why I hate doing these problems. There's so much to know, just like, and then I got to like figure out how to actually do these things. Well, listen, don't give up the ship just yet, okay? I'm trying to tell you what you need to work on in order to be organized, okay? And in geometry, when you're dealing with proofs, you're not going to, really, be effective at this unless you can reference all this stuff. But listen, if your notes aren't where they need to be, just improve them. You can definitely go back and get yourself, up to where you need to be. Okay, it's just going to require a little bit of work. All right, now here comes the fun part. Okay, so after we have a sense of that we're going to be doing a two-column proof, we know our reasons that we can give. Okay, we kind of went over some examples of properties of algebra and properties of congruence. Well, all of that, okay, is just the tools. Okay, now we need to get creative, and really our first move here, those are kind of the rules of the game. But the game itself, in order to prove something, right? If you're gonna, like, here's you and here's your brother or sister, and you guys are having an argument over something. Now the game is, hey, I gotta convince this person that I'm right and they're wrong. Okay, that's the game. So now that we know the rules, we need a game plan to prove our point. Okay, so this is where it becomes fun. Okay, so let's take a look at the situation here. And we're saying, okay, given angle 1 is congruent to angle 3. So we got to understand these words. So here's angle 1, and we're saying it's congruent to angle 3. In other words, this angle and this angle are equal. We're like, okay, all right, that's given to me. I want to prove that these two lines are parallel, okay? So it's probably going to help us to review a lot of theorems and postulates about parallel lines. So this is the key, okay? This proof has to do with proving two lines are parallel. So what you want to be thinking in your little thinking cap there is you're going to be saying to yourself, okay, what do I know about parallel lines? So you need to be thinking about all the theorems you know, all the postulates you know, and like the definition of parallel lines. You got to be thinking, okay, what do I have? Okay, and all this stuff should be in your notes. Okay, now we want to be thinking about, in this particular problem, a certain theorem that can help us out, but I'm kind of jumping the gun here. So you're like, all right, I know a lot about parallel lines, and I'm seeing that 2 and angle 1, these two angles here, okay, because I didn't, in the given information, angle 2 wasn't mentioned, but these two angles are what kind of angles? They're corresponding angles, okay? And there's a theorem you're saying, oh, corresponding angle. Wait a minute, I remember seeing a theorem that said if two corresponding angles formed by a transversal and two parallel lines, okay, if two corresponding angles formed by a transversal and two lines, okay, if these two corresponding angles are congruent, then these lines are parallel. Now, I kind of just paraphrase that, but that's effectively what a theorem would look like. Now, in your book or in your course, you might be like, your teacher might have that as theorem 1 or whatever. It's going to be categorized, but you're going to have some sort of theorem that you learn that says, hey, if you have a transversal and two lines and these corresponding angles here, okay, or corresponding angles are congruent, well, that is telling you that the lines here are indeed parallel. So that's what we want to shoot for. Our game plan is like, oh, okay, so why don't we get construct a plan to argue that angle 2 and angle 1 are corresponding. Now, can we do that? Absolutely, okay? So we can say, angle 3 and angle 2, all right, these two angles right here are what we call vertical angles, okay? You're like, oh yeah, vertical angles, these two angles are congruent, right? In other words, they're the same. So this is the same as this, okay? 3 is the same as 2, and 3 is the same as 1, so therefore 2 is the same as 1, okay? So I can say, okay, 2 is the same as 1, and that's what I need. Okay, 2 is the same as 1, meaning that these corresponding angles are congruent. Therefore, I can make a final statement that these two lines are parallel. So this is where the interesting part comes in. You need a kind of a game plan. Don't start doing a proof until you construct this. Now, if you saw another strategy to get to this, or maybe you're using another theorem or whatever the case is, there are other ways you can do this, okay? But you want to kind of look at the most elegant, most effective, efficient way to prove your point. But that's okay. I mean, as long as you get it right, that's really the main thing here, okay? All right, so with that being said, if you want to try this on your own before you see my final answer, what you want to do now is make a statement, okay, which is typically going to be the given, and then you're going to use a definition, postulate, property of algebra, congruence, or theorem to kind of walk through, okay, and your final statement will be that your final statement is always going to be line L is parallel to line M in this particular case because of your final reason. Okay, so this is what you're going to think through. We have a game plan, so now we have to kind of tell that story. All right, so let's go down here and actually do this now. If you want to, play around with this for a second, go to pause the video and construct the proof. But let's go ahead and see my work. Again, you could have done this maybe a different way, but this is going to be the most direct route to take. All right, so 2-column proof for this. So given angle 1 is congruent to angle 3, prove that line L is parallel to line M. Of course, that's the problem. Let's go ahead and get into it now. Okay, so angle 1 is congruent to angle 3. That is given. All right, this is typically going to be your first move. And I kind of think of this as playing a chess game or checkers game. You're like, okay, you have to make one move, and typically repeating the given information is almost always your first statement. So just get in the habit of just putting that down. Boom. So now I'm going to say angle 3 is congruent to angle 2. So remember over here, I'm already being told that 3 and 1 are the same angle. That's given information. But in order for me to make my little case here, I need to justify that 3 and 2 are the same, and 3 and 2 are the same because of vertical angles. So that's my next reason. I can't do anything until I make establish that fact. So angle 3 is congruent to angle 2. Why? Because vertical angles. Okay, vertical angles are congruent. All right, 3 and 2 are vertical angles by definition, and vertical angles are congruent. So that is the definition of vertical angles. Okay. All right. So there is somewhere along the lines you learned about vertical angles. That is a definition. Okay. So now let's move on to our next statement. I'm going to say angle 1 is congruent to angle 2. All right. So now that I made that point, 3 is equal to 2. 3 is also equal to 1, so therefore 2 is equal to 1. Remember, this is my next strategy. I want to show that these corresponding angles are equal. So let's go ahead and state that, but I got to back it up. So angle 1 is congruent to angle 2. Why? Because of the transitive property, okay? And to be more technically correct, you could put the transitive property of congruence. Recall, let me go up here real quick. Remember what the transitive property is, and that is this. If A is equal to B, okay, so here we had if angle 1 is equal to angle 3, which we already know, and angle 3 is congruent to angle 2, okay, therefore A is equal to C. So in other words, angle 1 is congruent to angle 2, and that's what we want. But that is a illustration of the transitive property. Now, because we're not using equal signs, we're using congruent signs, transitive property of congruence. Oh boy. Okay, so, if you're struggling with proofs, there are, they're like a little puzzle you got to figure out, like a little Rubik's cube or what Rubik's cube. Gosh, I remember those things came out in the early 80s. They were driving people crazy. Typically, people would just take them apart and put them together the right way. You can't necessarily do that with a problem like this, but you can get better at math, and that's the whole idea here. Okay, so transitive property. So we're pretty good to go. We've proved our up to this point, angle 1 and angle 2 are congruent. And this is really kind of the secret to our kind of game plan here. As long as we could prove that these corresponding angles are congruent, well, that can only happen if the lines here, these lines formed with this transversal, are parallel. Okay, but what basically establishes that? Well, we have a thing called a theorem that backs this up. And just to use a paraphrase, so now we can make our justification. Hey, line L is parallel to line M. If I've been saying angle, I apologize. I am speaking I'm trying to stay focused here. So even myself doing, teaching this is, can be challenging sometimes. So line L is parallel to line M. Okay, that's my final conclusion, but I got to back it up with a theorem. It says if two lines cut by a transversal, okay, and the corresponding angles are congruent, then those lines are parallel. Okay, that those lines are parallel, and this is an example of constructing a geometric proof. Okay, it's pretty involved, all right, no doubt about it. And if you're having, problems doing proofs, that's pretty normal, okay, even for very good students. But hopefully this little video here helped you kind of go from this little face to, let's kind of give it a little bit better face here, maybe to like this face, be like, okay, I think I can do this. I can assure you, if you continue to practice, you'll end up with a nice little happy face. You'll be like, I am so smart. I always show my teacher that I can do these problems every single time, and you can. So don't get stuck in this situation, all right? What you have to do is, learn the fundamentals, get your bearings, improve your notes, get yourself organized, and then you're like, okay, now I'm ready to kind of go. And as you continue to do problems successfully, you gain confidence, and eventually you'll be able to handle these problems. But these problems are going to come up over and over again, okay, especially in a geometry course. And if you continue on in more advanced mathematics, you're absolutely going to be having to think in terms of proving stuff. Okay, so hopefully this video helps you out. If that is the case, don't forget to like and subscribe. If you need more help with geometry, anything geometry, definitely check out my geometry course. You can find it in my math help program. I also have some geometry notes down below, but that's not going to help you out nearly as much as my geometry course. But with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.